I know where there's some, right here in the hall, clerk.
No, Molly, I have
Okay, welcome back. This time we're going to tackle the output transformer, which I have here. This is the output side. This is the input side with its center tapped transformer. I thought we'd start by, again, the issue is this is apparently a generic output transformer with many options. It doesn't fit inside the case like it needs to, inside the chassis rather. So I just want to see how close it is. I will replace this no matter what, but I just want to see when it was installed how close it was to what we know about the requirements are for the original output transformer. And we'll start with the resistance measurements for the secondary side. According to the schematic, it's supposed to be 0.3 ohms across the secondary of the transformer. So we'll see what it is. Let me turn the light on here. I don't know if the wire there to grab. And the answer is roaming around somewhere between 0.6 and 0.8 ohms, 0.9 ohms. It should be 0.3. So that's not quite right. Let's check across the primary. And the primary leads, I've got these marked here to where they went. This is the brown wire. It went to the plate of the second 6v6. So we know that's one side of the output, and the other side should go to the other 6v6. Yeah, here they are. So this is across the length of the center tapped primary. And this should be 300 ohms on the side, so 600 ohms total. And we'll see what this is. And far from 600 ohms across the, it's 266. Let's confirm that I do have my labels correct. We'll check from the center tap, or what I believe is the center tap, to the other side. Yeah, so 137 ohms. So this indeed is the center tap. 137 ohms to that side, and 129 to the other. As I said, the schematic calls for 300 on a side, which suggests to me that this transformer probably can be configured correctly. I mean, it's got, well, all it's got is the 3 input leads, so they're fixed. You could select multiple outputs, I guess, but so the impedance that the 6v6s are facing to drive the speaker are wrong. These should be 600 ohms across the full length of the transformer, and it's not. It's about 300 total instead of 300 and 300. So it's the wrong transformer in the first place. Well, good to know. Don't need to go through the business of trying to find out what its lines ratio is, because it doesn't matter. It's wrong no matter what we do, no matter what we measure. So that's resolved. That's something resolved. And it was quick. I don't know if it took 5 minutes even. Oh, 5 minutes exactly. All right. By the way, these are parrot probes. And I don't get any money from them. I just spend money on them. These are the finest probes you can buy, I think. Oh, I'm sure there's some better, but it comes in 4 sizes, 3 or 4, I can't remember. Here's a smaller set, and by smaller I mean the that gap right there. Let me see if I can get this closer to the camera. There's a gap right here, and this size might be 2 millimeter. This size is good for printed circuit board circuits. And the one I use for old radios, because you need to grab big things, is the 4 millimeter hook. But it has this fixed blade. You can jam it into a solder joint, or if you want to get your hands off, you can hook it around a wire, and it holds like crazy. It's really handy to get on and off. So much better than alligator clips. I can't stand alligator clips. These work. So if you're ever in the market for some new probes, try these. The Parrot, P-A-R-R-O-T probes. A number of people sell them. I don't know where they're made or anything else. Good for 1000 volts, 10 amps. My recommendation for the day. Larry had asked if I had checked the can dome resistor, and it was absolutely fried, probably shorted to ground, probably the cause of all the problems. But I thought I'd take it apart and see how bad it was, and it was pretty bad. Mostly carbonized, as you can see. Got a couple of pieces of scrap metal out of it for the recycling bin, and that was it. Finished the survey of the coils, transformers, and so on. So let's start. I'll share what I found. We'll start down here in this corner in the power supply region. Good in this section is the power transformer. It ohmed out good, well within the tolerances of what the schematic calls out. So even though it wasn't the original transformer, it will work for the moment. News is, of course, that this audio output transformer is completely wrong, and I'm not even going to bother with it. I'll replace it with something. The other things I discovered in this section in particular was this choke right here is missing, and this dual safety cap thing is missing as well. No great loss. I'll replace this. The choke, I don't know, it had more to do with providing clean power to the phono socket, and that may want to go back in. I don't know. I'll have to when I get to the phonograph, I'll think about that some more. Other stuff going on in here. Most of the carbon resistors that I checked, and I just did a spot check. This guy, for example, this guy here, they're all the carbon composite resistors are out of tolerance and gone high, as you would expect. The can dome replacements are good solid resistors, so they are of the right. In fact, they're a little bit big. in terms of wattage, but the resistance here and with the other one up here are fine. So that's this chunk of the world. Let's swing over to the RF section. Tuning stages of the radio. These guys all tested good, which was really good news. The slugs appear to be just fine. That's all good. That's all good. And over in the first RF stage, which is right here, and this is the first IF for FM. This is the first IF for AM, and the FM side looks good. So those guys are good. The AM side, that secondary is fine. This primary is bothersome a bit. On one schematic, well, it's not bothersome. The schematic is the bother. On one copy of the schematic, it looks like that's supposed to be 0.5 ohms. On the other schematic that I've come up with, it looks like it's supposed to be 5 ohms. And what it measures is 4.7. So I'm declaring that one a good one too. I will choose to believe at this point that the 5 ohm number is the correct number for that transformer. Let's slide on over into the secondary. The secondary IF, same setup, FM here, AM here. These transformers tested good, so we'll give them green stripes. The third IF, FM and AM, again, FM looked good, and the AM primary this time looks good. This secondary is a little bothersome. The schematic calls for this to be a 22 ohm coil, and what I get on it is 11 ohms. So this one will mark as questionable for now. Then we go over to the discriminator transformer, and this side of it seems just fine. It's got its 3 ohms or so, and this side does not. This side is supposed to be 5 ohm primary, and it tests open. So this discriminator transformer might have an issue. He said, might have an issue, does have an issue. So that's going to have to be, well, they're all, here's the other bad news, is my guess is every one of these, this one in particular has three caps in it. All the rest of them have 2 each. This one has 3. And I'll bet you all of them are silver mica, and I bet you every one of them probably has the dread silver mica disease. So that's going to be a lot of work, unfortunately, but it probably has to be done. And I guess my feeling is at this point, there's not much point in hoping that they won't require work. I might as well set up a production line and just replace all these silver mica caps. Well, again, and I'm speculating. I haven't taken one apart yet, but it's a pretty safe guess that that's what's in there. So I've got bad news here, and I've got some bad news potentially here too. The resistance measurements aren't quite right, or by half. Measures 11, should be 22. I've probably got more than one of these caps with silver mica disease, which was, I ran across a website of a guy who repairs radios, and he says, I don't repair anything after 1950 because of this problem, because of silver mica disease. He just doesn't bother. It's not worth his time. And I understand that, but I don't do this for a living, and I don't even try to make any money off of it, so all I've got's time. So, what's next? Well, I've got to solve the output transformer problem. I think I've found another chassis I can turn into a donor chassis. I'll let you know the next video. Right now, I'm going to start the cap replacement business. I'm going to go through this and replace every cap. I've also, or all the waxy caps, I should say, all the leaky waxy caps. I've got to also measure every resistor in here because a lot of them, most of them are carbon and they are drifting up. Need to bring that back into spec. And then I'll start popping these transformers and seeing if indeed there is a silver mica capacitor in there and cure it as appropriate. Let's see, I think that's all for this week. Yeah, that's where we are. I can't do any more discovery to speak of on the radio. I have a general idea of what's wrong. I know what needs to be done next. So I'll get started. Next time we're back, we should have it recapped. And we'll have recapped, all the resistors measured, and looking into the transformers, the IF and the discriminator transformer in particular. Okay, that's it. See you next time. Take care. Be safe.